We are given that 5 liters of brine is flowing into the tank every minute. This brine contains 0.2 kgs of salt per liter, and therefore the rate at which salt is flowing into the tank is equal to 5 times 0.2 or 1 kg per minute. Now we are given that at t is equal to 0, the tank contains 100 liters of solution. We are also given that the solution initially contains 0.1 kgs of salt per liter, and therefore the amount of salt initially present in the tank is equal to 100 times 0.1 or 10 kgs. Now in time t, 5 times t liters of brine has flowed into the tank, and 5t liters of the mixture has flowed out. Therefore the amount of solution in the tank at time t is equal to 100 liters. Let's assume that there is x kgs of salt in the tank at time t, and therefore there is x upon 100 kgs of salt per liter of solution present at time t. Now the mixture is flowing out at the rate of 5 liters per minute. We've just assumed that this contains x upon 100 kgs of salt per liter of the mixture, and therefore salt is flowing out of the tank at the rate of 5 times x upon 100, which is equal to x upon 20 kgs per minute. Therefore the rate of change of amount of salt in the tank is equal to the salt in rate minus the salt out rate, which is equal to 1 minus x upon 20 kgs per minute. And this is equal to dx upon dt, where x is the amount of salt in the tank at time t. Therefore, dx upon dt is equal to 20 minus x upon 20. Separating the variables, this can be written as 20 upon 20 minus x dx is equal to dt. Integrating both sides and adding the constant of integration c on the right hand side, we get minus 20 times ln of 20 minus x is equal to t plus c. Now we are given that at t is equal to 0, the amount of salt x is equal to 10 kgs. Substituting this in the above equation, we get minus 20 times ln 10 is equal to c. Substituting the value of c in the above solution, we get minus 20 times ln of 20 minus x is equal to t minus 20 times ln 10. Therefore, t is equal to 20 ln 10 minus 20 ln 20 minus x. And therefore, t is equal to 20 times ln of 10 upon 20 minus x. This can also be written as e raised to the power t upon 20 is equal to 10 upon 20 minus x, or 20 minus x is equal to 10 times e raised to the power minus t upon 20. It therefore follows that x is equal to 20 minus 10 times e raised to the power minus t upon 20. This is equal to 10 times in brackets 2 minus e raised to the power minus t upon 20. Now let's assume that x is equal to 15 kgs at t is equal to capital T. Using the above equation, we get 15 is equal to 20 minus 10 times e raised to the power minus capital T upon 20. Therefore, 10 times e raised to the power minus t upon 20 is equal to 5, which implies that e raised to the power t upon 20 is equal to 2. Taking the log of both sides, t upon 20 is equal to ln 2, and therefore t is equal to 20 times ln 2, which is the required answer.